I'll show you how to maximize the total profit using total revenue and total cost functions using two functional forms. Let's start with the benefit function. BQ equals Q squared plus 50Q plus 22. And the total cost function is 3Q squared minus 2Q plus 50. Now, before using these two equations, I would like to show the intuition behind profit maximization. Let's start with the intuition. Now, profit maximization is indeed a cost and benefit analysis, but at the marginal level. What is marginal level? Which means we go incrementally, one by one. So we ask the same question over and over again for each and every unit that we produce. Let's say this is quantity, and this is our analysis. This is our decision. Okay? Now, we ask this question for the first unit that we produce. What is the marginal benefit of the first unit, and what is the marginal cost of the first unit? If the marginal benefit is greater than the marginal cost, then our decision is yes, let's go ahead and produce the first unit. Then we ask the same question for the second unit. What is the marginal benefit of the second unit and marginal cost of the second unit? If the marginal benefit is greater, then we go ahead and produce that unit. We do the same for the third unit, and if marginal benefit is greater than marginal cost, we produce that. And we do this until we come to a quantity which we call Q star. So for this specific quantity, we will come to a point where marginal benefit will be equal to marginal cost. And we will produce that, and that point is the point where the next quantity, Q star plus 1th unit, marginal benefit is going to be less than marginal cost. And this means we are not going to produce that unit. And the profit maximizing unit is Q star. Okay? So if the functions or in real life the production process is simple enough, you can do it unit by unit. But in real life, think about the production process that produces thousands, sometimes millions of units. So you cannot do it one by one. So the idea is to be able to find this Q star right here using the functional form. Okay? That is why we are taking the marginal benefit of the function, and we take the marginal cost of the function, cost function, and we set them equal to each other and then find the profit maximizing quantity. So let's do this for these two functions. If the benefit function is Q star plus 50Q plus 22, let's take the first order derivative with respect to quantity, which will give us the marginal benefit. This is called the marginal benefit equation. Q star is going to be 2Q plus 50Q is going to be 50, and the constant term 22 is just going to be 0. So the marginal benefit function is 2Q plus 50. Now if we do the same for the cost, this is going to give us the marginal cost curve, which will be 2Q star is going to be 6Q, minus 2Q is going to be minus 2, and 50 is going to be 0. So the profit maximizing condition is marginal cost equals marginal revenue. When we set these two equal, this is going to give us the profit maximizing quantity. So in our example, let's set 2Q plus 50 equals 6Q minus 2, and 52 equals 4Q, and this means Q equals 13. So when we produce 13 units, it is going to maximize our profit. So how much is our profit? Let's plug in 33 into these two equations, benefit and cost equation, right? So let's put this here. Okay, so benefit, your total benefit when you produce 13 units, which is the profit maximizing quantity, you'll see that Q square 169 plus 50Q 650 plus 22. Okay, this is going to give you 841. How about your total cost? Plug in 13 in the cost function, 3Q square, right, which is 507 negative 2Q minus 26 and plus 50. And this is going to give us 531. So our net profit is 841 minus 531, which is 310. And this concludes our discussion.